Guys, welcome back to my YouTube channel. So today we'll be talking about its transfer. So we are introducing what its transfer is all about, and we are starting with what is its transfer. But before we continue, don't forget to like, subscribe, and share to all your departmental groups. So what is its transfer? Its transfer deals with the study of rates at which exchange of heat takes place between a hot surface and a cold receiver. If two bodies at different temperature are brought into thermal contact, heat flows from a hot body to a relatively cold body. The net flow of heat is always in the direction of decreasing temperature. Thus, heat is defined as a form of energy which is in transfer between a hot source and a cold receiver. The transfer of heat depends upon the temperature of the bodies. So they're just trying to tell us that heat transfer deals with like study of how heat is transferred between two bodies. So now it's now from a hot surface and a cold receiver. So we have two different bodies and um temperatures are transferred. Heat are transferred. So it could be between the same temperature, like bodies of hot surface and a cold receiver, or two different temperatures, but it is sure going to flow from one surface to another. So it's usually a hot surface to a cold receiver, and the net flow of heat is always in the direction of decreasing temperature. Like the temperature decreases as the heat flows, temperature decreases. So let's say the temperature of the first one is of the hot body is like 90 and this cold one is like 20. So when there is heat transfer, the temperature decreases. So I said the net of flow is always in the direction of, okay, I've explained that. Thus, this heat is defined as a form of energy which is in transit between a hot surface and a cold receiver. So the transfer is like motion. It moves from hot source to a cold receiver. And the transfer of it also depends on the temperature of the body. So let's move to difference between heat and temperature. So difference between heat and temperature. In describing heat transfer problems, we often make the mistake of interchangeably using the term heat and temperature. There is a distinct difference between the two. Now, let's check out the difference between the two. Temperature is a measure of the amount of energy possessed by the molecule of a substance. It is the relative measure of how hot or cold a substance is and can be used to predict the direction of heat transfer. The usual symbol for temperature is capital T. The scale for measuring temperature in SI units are the Celsius and Kelvin temperature scales. On the other hand, heat energy is in transit. The transfer of energy heat is energy in transit. The transfer of energy as heat occurs at the molecular level as a result of temperature difference. The usual symbol for heat is Q. Common units for measuring heat are joules and calories in the SI system. So, temperature is just the measure of how hot or cold a substance is, how hot your water is, how cold your water is. That's basically what temperature is, and the symbol is in capital T, and it is mostly used. The scale that is for measuring temperature is usually in Celsius or in Kelvin. Then heat is energy in transit. It is the transfer of energy as it occurs. So it's the transfer of energy. Unlike temperature is just used to know that okay, this is how hot this body is, or this is how cold this body is. But energy is like transfer of energy. Sorry, I said energy. It is the transfer of energy from one body to another. So it occurs at the molecular level as a result of temperature difference. So it occurs as a result of temperature. So more like temperature is in heat, but it is just but temperature is just the measure of how cold or how hot the body is. Then the symbol for it is usually in Q. Common units for measuring it are in joules and calories in the SI system. So let's move to difference between thermodynamics and it. We've been treating thermodynamics for a while now. So let's know the difference between thermodynamics and it. So thermodynamics tells us how much heat is transferred, how much work is done, and the final state of the system. Why heat transfer tells us how or with what mode is it transferred. Sorry, how or with what mode is it transferred, and how at what rate is it transferred. Then temperature distribution inside the body. So thermodynamics tells us how much of the heat that is done, how much of the work that is done, how much of the heat that is transferred, then the final state of the system. So okay, heat transferred. Okay, so how much of thermodynamics is telling us how much of the heat that is actually transferred, how much of the work that is actually done, and the final state of the system. Why it's transfer tells us how and with what mode is the heat transferred. Now, heat transfer is not telling us the amount of heat that is transferred, it's just trying to tell us what mode is the heat transferred, what mode is it used to transfer the heat, then what rate of heat is transferred, then temperature distribution inside the body, like the distribution of temperature inside the body. So that's basically what heat transfer is all about. Thermodynamics telling us the amount of heat, the amount of work done, and final state of the system. Why it's trying to tell us what mode is used to transfer the heat and the temperature distribution inside the body. So let's move to the modes of the transfer. Like what modes is it used to transfer in a body. So how it can be transferred, which is like the mode of its transfer. How is it transferred? There are three different ways in which it can be transferred. We have our conduction, we have the convention, and we have the radiation. So these are the three ways in which it can be transferred from one body to another. So we are going to look into each of them. So the first one, conduction. Conduction is the transfer of heat from one part of a body to another part of the same body, or from one body to another. Usually a solid, which is in physical contact with it. Example, hitting a rod. So heat conduction occurs by the migration of molecules, and more effectively by the collision of the molecule vibrating around relatively fixed position. Conduction uses the Fourier law, which states that the rate of heat flow by conduction through a uniform or fixed material is directly proportional to the area normal to the direction of the heat flow and to the temperature gradient in the direction of its flow. Conduction can be through a plane wall, a composite wall, a cylinder, a sphere, and etc. So that is trying to tell us that conduction is the transfer of heat from one part of a body to another. So it can be between a body, like transfer of it between one body, or transfer of it between two bodies, and it's usually in solid state. And the body is usually in solid state, and there's usually a physical contact between those bodies. For example, it's a rod. So in this case, there are two bodies. What we are using to hit the rod and the rod. Sorry, yes, what like hitting the rod. So they are in direct contact with it. So that's why conduction deals with direct contact and between a solid state. So its conduction occurs by the migration of molecule, and more effectively by the collision of the molecules vibrating around relatively fixed position. So during the process of its transfer in conduction, there are migration of molecules and the collisions of those molecules. So conduction uses the Fourier's law, which states that the rate of its flow by conduction through a uniform fixed material is directly proportional to the area normal to the direction of its flow and the temperature gradient in the direction of its flow. So conduction uses the Fourier law, and it moves from to directly proportional um to the temperature gradient and to the area. So, and its conduction can take place, can be through plain wall, it can be through composite wall, it can be through a sphere, it can be through a cylinder. So we are going to move on to convention. So convention, it is a process of heat transfer that will occur between a solid surface and a fluid medium when they are at different temperatures. It is possible only in the presence of fluid medium. Example is cooling of hot plates by air. Convection is the transfer of heat from one point to another within the fluid by mixing of hot and cold portion of the fluid. So convection deals with a solid and a fluid. Like the fluid is important. If there are no fluid medium, then we can't have convention. So it's the process of heat transfer between a solid state and a fluid medium, and which are when they are at different temperatures. We know that they're always the bodies are usually at different temperatures, and it will be transferred. So the second definition says that is the heat transfer of heat from one point to another within a fluid by mixing of hot and cold portion of the fluid. So it is transferred when mixing portion of cold, hot, and cold portion of fluid. So heat transfer by convection occur as a result of movement of fluid on a microscopic scale in the form of circulating current. The circulating current may be set up either by its transfer process itself or some external agency. So it deals with the movement of fluid on a microscopic scale in the form of circulating current. So this current can either be set up by its transfer process itself. It can either be the circulating current can either be by itself or some external agent. So we have two types of convention. We have the free or natural convention, and I have the first convention. For the free convention, when circulating current arises from the heat transfer process itself. So we mentioned that the circulating current can either be by itself or some external agent. So if it's by itself, it's a natural or free conduction convention rather, which in boiling of water. When water is boiling, there are usually like circular stuff inside. So, and this process is by itself, is not by an external agent. So we can call that a natural convention. Then we have our first convention. When the circulating currents are produced by an external agency, such as an agitator in a reaction vessel, pump, fan, or blower. So when there is a agitation in a reaction but vessel, then that means the first condition is by an external. The circulating current is happening by an external agent, and if we don't know what agitation is, it's like mixing of something. So that's what agitation is all about. So it can be, e.g., it floats a liquid through pumped through a heated pipe, cooling exchange in heat exchanger and in nuclear reactors. So convention uses the Newton's law of cooling, which describes the rate at which an object exchange heat with its surrounding when there is temperature difference. So then it uses the Newton law of cooling, and it describes the rate at which objects exchange heat with its surrounding when there is temperature difference. So let's move to radiation. So radiation, the heat transfer from one body to another without any transmitting medium. So radiation deals with the heat transfer of one body to another without any transmitting medium. For convention, it has to be a direct contact, and it has to be from a solid surface. For convention, it has to be a fluid has to be present and a solid body. But for radiation, there are no transmitting surfaces, there are no transmitting medium. So it's an electromagnetic wave phenomenon. Example, radiation sun to earth, use of energy from the sun in solar energy. So it deals with electromagnetic wave. So it depends upon the electromagnetic wave as a means. It depends upon the electromagnetic waves as a means of transfer of energy from one source to receiver. So from the hot source to the receiver. So it deals with electromagnetic wave. So mechanism of transmission is photon emission. This mode of heat transfer does not require any medium. It's been said. The significance of this is that radiation will be the only mechanism for heat transfer whenever a vacuum is present. So whenever a vacuum is present, we know that we use radiation. So if there's a solid, we know we use conduction. If there's a fluid and a solid, we know that we use. So if there's a solid, we use conduction. If there's a fluid, and if there is a fluid present, we use convection. And if it's vacuum, if there are no transmitting medium, we use radiation. Radiation uses the Stefan-Boltzmann's law, which states that radiation energy from a black body is proportional to the fourth of its absolute temperature at the surface of the radiator. So that is radiation uses Stefan-Boltzmann's law. So for convection uses the Farrell's law of conduction. Conduction uses the Farrell's law of conduction. Convention uses Newton's law of Cooling, and radiation uses Stefan-Boltzmann's law. So that's that about the modes of heat transfer. So let's move to how you can apply it, or where you can apply heat transfer. So application of heat transfer, where each application means where can be transferred basically. So the first place is its exchanger, second is HVAC system, third one is cooling of electronic components, then industrial drying and evaporation, biomedical applications, e.g. artificial organs. So that's where heat transfer can be applied, and that will be the end for today's for this section. So guys, do not forget to please like, subscribe, share to your departmental groups, and to everyone that you know that is going to need this video. So until next time, see you guys later. Bye.